Welcome to week 3 and water management in homestead design. In permaculture design, the principle to keep in mind when designing how you manage water at your site is catch and store energy. Let's take a look at the desired conditions for water at your site. These desired conditions are developed from Brad Lancaster's Water Harvesting for Drylands. You will need an adequate quantity of water to meet your needs at any time of the year. We'll also take a look at redundancy of water and how it is stored at your site. Think about how you'll provide more than one water source in the case of drought or water restriction. You will also need a quality of water to meet your needs, matching the quality to the use of the water. And the last one to keep in mind is that water is always released from the site clean. First, let's look at quantity. You're going to know the background of your region and how much precipitation your area receives every year. Is this precipitation evenly distributed throughout the year, or are there rainy or dry seasons? What sources of water already exist at your site? Where does water enter your site, and where does it leave? How much water do you require to water your plants 1 inch of water per week? Let's do a short brainstorm. Take out a sheet of paper and write down 3 ways that you could have access to water if your primary water source failed. Knowing where your water comes from and what an alternative source would be are very important as far as food production and general homestead tasks. Now let's look at a few water harvesting principles, also developed from Brad Lancaster's book. First, begin with a long and thoughtful observation of the way that water flows through your landscape. Start at the top and work down your watershed. Start small and simple, and always plan an overflow route and manage the overflow as a resource. Try to maximize living ground covers to protect the soil from erosion. The best place to store water is high in the landscape so that it can be gravity fed to areas that need irrigation without the use of electricity and pumps. The least expensive place to store water is in the soil. We like to say slow it, spread it, and sink it when considering water flow through our sites. Swales are water harvesting ditches on contour. They're at the same elevation laid out across a slope. Swales can be very large or designed on a micro scale. Swales catch water flowing down slope and sink it into the ground where it accumulates and forms a lens of water that passively irrigates plants on the downslope mound, which is called the berm. The key point is a point on the slope where the slope changes from convex to concave. The key point is used as the starting point for swales because all of the upslope water will flow to this point and can be then caught in a swale system. This study, Seasonal Nutrient Dynamics of Forested Floodplain Soil, influenced by microtopography and depth, shows us that swales catch a lot of nutrients in the landscape. The seasonal nutrient dynamics were measured in the study, and nitrogen and phosphorus levels were consistently higher in swales than on slopes. The high frequency of flooding at swales resulted in greater nitrogen and phosphorus enrichment and led to calcium, nitrogen, and phosphorus accumulation in swale soils. You don't need any fancy equipment to lay out swales along contour lines or lines of equal elevation. Watch this video to find out how to use a simple tool called an A-frame to lay out swales. These photos show a small excavator digging a swale on our property. But swales are very easy to dig by hand for small areas. At our site, we modified the typical swale basin by using a checkmark shape. The checkmark swale is much easier to mow and keep maintained than the traditional rounded swale. You can see our new swale on the photo on the left, which was planted with clover and a mix of other species. The white tubes are tree protectors for newly planted Asian pear trees. In the year 2 photo, you can see the Asian pears placed next to the white buckets and the chickens ranging along the swale. Here's a view of the whole swale system. You can see here how the water flows off the slope into the swale and then makes its way up to the top of the swale near the rock wall. The overflow is directed to the driest portion of the site. This photo shows how the swale directs water up to the top of the key point so that it can overflow into the next swale. As water overflows from the first swale, another swale is sited to catch that overflow as a resource. Here's what the swale looks like after a heavy rain. Water will not stay in the swale for more than 24 hours. Take a look at these videos to learn more about swales. If you're interested in smaller scale water catchment systems, take a look at these rainwater catchment videos. This video is called The Top 6 Reasons to Get a Pond, and it gives you a very comprehensive overview of all the functions of a pond in the landscape. If you're not familiar with gray water systems, take a look at this video. These two videos showcase very small scale irrigation systems. If you're working on a small urban site, take a look at the Oyas and Wet Pots video. If you're looking for large-scale water management strategies at a large site, check out these keyline design demonstrations. This video series called Greening the Desert is one of the most convincing demonstrations of successful water harvesting design in the world. A desert was brought back to life using swales and permaculture design.